For nearly 2 weeks it vanished behind the sun, silent, invisible, lost in solar glare. Then, just as the cameras came back online, 3I Atlas appeared again. And what they recorded didn't match what anyone expected. This isn't a normal comet. It's an interstellar traveler, racing through our solar system at over 90,000 kilometers per hour. And it's now at its closest point to the sun. New coronagraph footage confirms something crucial. Its orbit hasn't changed. No sudden deviation toward Earth, no unexplained maneuver. But while 3I Atlas was hidden behind the sun, the far side erupted with 3 massive solar flares, each one ejecting plasma straight through its predicted path. In the aftermath, telescopes detected a faint, rhythmic heat pulse, stronger than sunlight alone could explain. Was it chemistry, a natural plasma effect, or something we've never seen before? As the object re-emerges, scientists are watching closely. With perihelion, a supermoon, and solar storms all aligning, this short cosmic window could reveal more than ever about how interstellar objects behave inside our solar system. Stay tuned. This is your real-time status update on 3I Atlas and what's really happening behind the sun. For nearly 2 weeks it disappeared behind the sun, silent, invisible, lost in the glare. Then, new solar observatory footage revealed it again. And what scientists saw didn't quite fit the rules. This is 3I Atlas, an interstellar object traveling through our solar system at nearly 90,000 kilometers per hour. Fresh coronagraph data confirms its orbit remains stable. No sudden turn toward Earth, no hidden maneuver. But something unusual appeared in the thermal readings. A steady, pulsing heat signature coming from its core. As 3I Atlas passed through a series of massive solar eruptions, one of the largest CMEs recorded this month crossed directly through its trajectory. Instead of destabilizing the object, it brightened, briefly, as though reflecting or reacting to the solar blast. Researchers believe the pulse may come from trapped gases or internal dust activity, but others note that the energy pattern repeats at near regular intervals, something no known comet has shown before. With perihelion, a supermoon and active sunspot clusters all overlapping in late October, astronomers are watching closely. Whether this is a natural outgassing cycle or evidence of something we've never seen, one thing is clear: 3I Atlas continues to challenge every assumption about interstellar visitors. Stay alert. Stay curious. This is what's really happening beyond the sun. In the days that 3I Atlas disappeared behind the sun, something extraordinary unfolded. On the far side, 3 massive coronal mass ejections erupted, each one launching billions of tons of plasma directly through the object's projected path. When solar storms hit a comet, we expect turbulence, a blown-out tail, a spike in brightness, a burst of gas. But this time, the data didn't follow that pattern. Instead, telescopes recorded a steady, centralized heat source, pulsing rhythmically from within the dark core of 3I Atlas. It wasn't random. It repeated. Scientists quickly ran simulations. Was it trapped carbon dioxide? Ice pockets venting under extreme heat? Or could magnetic reconnection near the nucleus cause such a signal? Meanwhile, early images from a Mars-orbiting probe, which reportedly caught 3I Atlas in its field of view, remain unreleased. NASA has yet to comment, fueling theories online that something unusual was captured. Then came another anomaly. The tail direction flipped, briefly pointing toward the sun before returning to normal. Experts explain that this can happen naturally during solar wind reversals, but the timing, just hours after the heat pulse, keeps the debate alive. Whether it's rare physics or something truly new, 3I Atlas is behaving unlike any comet we've seen before. Over the past week, headlines and social media clips have taken 3I Atlas from a simple interstellar comet to a rumored alien probe, complete with claims of engineered light, pulses, and course corrections. But here's what the data actually says. No credible observatory has recorded any controlled propulsion, artificial radio pattern, or trajectory inconsistent with natural gravity and solar radiation pressure. The slight orbit adjustments seen so far match what we'd expect from outgassing jets. Normal cometary behavior as frozen material vents in sunlight. The signal some online users pointed to. It was a narrow-band telemetry echo from a satellite passing through the same frequency window. Not from 3I Atlas. Meanwhile, NASA, ESA, and several university observatories confirmed that the object's albedo, reflectivity, and heat curves still fall within known comet parameters. In other words, nothing alien, nothing impossible. Yet, still, scientists admit one truth: it's unique. Its interstellar origin and the strange consistency of its core glow don't fit perfectly into our catalog of known bodies. That's why researchers are watching it closely. Not because it's a ship, but because it's a chance to study how matter behaves after traveling light years through deep space. For now, remember, no panic, just perspective. Speculation spreads fast, but science takes time, and 3I Atlas is still writing its own story. As 3I Atlas nears its perihelion, the closest point to the Sun, this late October to early November window becomes the most critical phase of its journey. For the next few days, the object will pass behind the Sun's glare, invisible to most telescopes. But that's exactly when astronomers expect to see the most change. In brightness, tail structure, and possible fragmentation. Add to that the timing, a supermoon, active sunspot clusters, and an already charged solar wind. Together, these create a perfect setup for enhanced geomagnetic activity on Earth. If solar flares interact with comet dust or the interplanetary magnetic field, we could see visible auroras stretching unusually far south, and minor disruptions in satellites or radio signals. For observers, here's what to watch. After October 31st, look near the eastern horizon before dawn. If Atlas survives perihelion, it could brighten rapidly and develop a long ion tail visible even with small telescopes. Watch for sudden shifts in tail direction. That's how scientists detect solar wind events in real time. Why it matters, whether Atlas behaves like a comet or something entirely new. It's a live experiment in cosmic physics, one unfolding right above us. Stay curious, stay grounded, and remember, the best discoveries often begin with the simple act of looking up. As 3I Atlas drifts back into the cold dark beyond the Sun, one thing is certain. We are witnessing a story that stretches far beyond our planet. Every image, every data point, every spark of curiosity brings us a little closer to understanding what's really moving through our solar system. Whether Atlas turns out to be just another comet, or the most unusual interstellar traveler we've ever seen, it reminds us how much of the universe still hides in plain sight. The strange jets, the perfect orbital stability, the chemistry that shouldn't exist, all of it fuels the same human instinct that built our telescopes in the first place, to ask, what if? Over the next few weeks, scientists will keep tracking it. Amateur astronomers will share their images, and new observations may rewrite what we think we know about these visitors from the stars. And when 3I Atlas finally fades from view, the questions it leaves behind will light the next chapter of exploration. Stay tuned for updates as we follow the data, not the drama. Drop your thoughts, theories, and sky captures in the comments. We read them all. And if you want to stay ahead of every discovery, make sure to like, subscribe, and turn on notifications. The universe is talking. All we have to do is keep watching.